Okay, students, on the very high demand, many students requested that sir make a video on equivalent concept. That is one of the difficult topic, and we are struggling up with this problem. We are struggling up on this topic many questions. So kindly make a video about the equivalent concept. And today I am making a video on the equivalent concept. And all these concepts are made so that you can solve the questions anywhere, any questions related to equivalent factor, equivalent concept, you will be able to solve with this complete explanation, easy explanation about this. This is a high scoring concept, and you are at the which chem where as per your demands, when you feel a problem, just kindly send me message through the comment section whenever I get time. Then I will according to your requirement. We are in the initial stage of this YouTube channel, so I want that all of you should help me out and get help to other people also by subscribing and sharing and giving a like, and mention your difficult topic on which topic you wanted to make a video. Then according to my time schedule, I will make a video and make this chemistry easy for all students so that everybody should not struck your rank because of the chemistry. High scoring subject among yourself should be the chemistry. Okay, so now we are in the equivalent concept. Okay, so in the books what they will find EQ, they will find sometimes they will write MEQ, but people are very worried what is this MEQ, how you can find out, how are the ways. Okay, so simple equivalence in terms of the milli. Okay, like liter, milliliter, then it is like that only equivalent and milli equivalent. Okay, so when reaction is complete, let it be redox reaction, let it be acid base reaction. When we say that reaction is complete, then equivalent of all reactant must be equal to equivalence of all product. Okay, that is the completion condition for any reaction, irrespective of any type of reaction. Equivalents of all reactant, each reactant should be equivalents of each reactant, other reactant also, all product also. Okay, so main problem is that what is equivalent, what is milli equivalent only, and how they can find out, that is also people are not able to understand. Because of that, chemistry is becoming a difficult. Don't worry, be with me and sure tell me your problem, as the one two few students informed me about this topic, then I am going to make it easy. Understood? So there are the three methods. How many methods? Three methods to find out EQ or MEQ. Understood? So first method, if you're given with normalities, simply multiply that normality with volume. Normality into volume, you will get equivalence. Normality, if volume is in milliliter, then you will get milli equivalents. What you will get? Milli equivalents. So don't worry. Suppose deci-normal. Okay, question is given that 10 ml of deci-normal. Question they will give like this. Okay, 10 ml of deci-normal. Okay, so what you can find out? Milli equivalent find out. Okay, now deci means 1 upon how much? Deci, centi, milli. Deci means 1 upon 10. Okay. Centi means 1 upon 100. Milli means 1 upon 1000. Deci normal. So 1 upon 10 normality. Okay. Into volume is how much? 10 milliliter. So if milliliter, you will get milli equivalent. If you want to convert into liter, then you will get what you will get? Equivalents. Okay. So for that easy purpose, I am taking that 10 into 10. That means 1 milli equivalent. What it is now? 1 milli equivalent. Okay. So like this, you can find out when normality is given. Simply what you will do, you will multiply that normality with the volume. Then what you will get? Milli equivalent you will get. What you will get? Milli equivalent you will get. If volume is in milliliter, you will get milli equivalent. If volume is in liter, then you will get equivalents. Okay, this is one way. I think now it is understood. Second way is equivalent. If you want to find out, simple. Mass is given, you divide with the equivalent mass. Mass is given, what you will do? You will divide it with the equivalent mass. Okay. Then you will get what? Number of equivalents. What you will get? Number of equivalents. Okay. Directly you will get equivalents. If you multiply it with 1000, then you will get milli equivalents. Understood? Suppose, let us take H2SO4. Okay. So H2SO4 equivalent mass is 49. Okay. Question is given 4.9 gram of H2SO4. Okay. So simply 4.9 divided by 49. Like this, these are the equivalents. So when you multiply it with 1000, what will get? You will get milli equivalents. Is it understood how to use this formula to find out equivalents? Simply divide the given mass with the equivalent mass. Suppose if question is not given with the mass or equivalent mass you don't know, then what you will do? You will do mass by molecular mass divided by equivalent factor. Equivalent mass is just nothing but mass upon molecular mass upon equivalent factor. Okay. Now the question will be what is equivalent factor? Okay. If you know this already, that means this video is not for you. You can just skip it. You can enjoy your life. If you don't know how to find out equivalent factor, what are the conditions to find out equivalent factor, then only you are required this video. Okay. So I want that only needy students should see this video. Is it understood? Okay. Okay. Next topic, how to find out equivalent factors, methods of finding equivalent factors. Is it understood, students? Now, first and foremost thing is for acid there is a method. Second is for base there is a method. Third is for salt there is a method. Fourth is for ions there is a method. And fifth is for a redox change there is a method. Okay. So these are the methods we are going to learn it. Okay. If you already learned these methods, then it is well and good. Suppose if you have not learned this redox change, you just skip till the time you get this heading. Okay. If you don't know base, you stay forward up to base. If you don't know from acid itself, you learn acid and skip all as per your situation. So use this video. Okay. So pause and forward is in your hand. I want that if you see the entire video, some points may be covered which you have not listened. Okay. So nobody is complete. Nobody, even me also, I am not complete. So I may give you some points. I may give you some new points which you don't know. I may give you points which already you know. That's up to you. Understood? So for acids, okay, let us start with the from acid. Okay, equivalent factor. What is the formula? Equivalent factor is equal to number of replaceable H plus. Okay, this is very important. Ionizable hydrogen, number of replaceable, number of OH. Like this, they will give different formula, different places, different books. They will use different words, but in examination, you should know the concept. Okay, like HCl. On dissolving, it will give you H plus and Cl minus. So equivalent factor is how much? 1. Okay. Now if I take HNO3, equivalent factor is how much? 1. Okay. If I take H2SO4, okay, equivalent factor is how much? 2. Like that, these are all very easy questions. Okay. But the main topic we are going to cover is here. Okay. All equivalent factors are not hydrogen. All equivalent factors are not number of hydrogen. Okay. Now let us take HCOOH. What is this? HCOOH. So number of hydrogens are how many? 2. So equivalent factor should be how many? 2, but not 2. Okay. Equivalent factor is how much? Equivalent factor for this acid is equal to how much? 1. Is it understood? And sometimes H3PO3, sorry, H3PO4, H3PO3, H3PO2. See, all of them appear to be same or not. So all of you should feel that equivalent factor must be 3, 3 and 3 because they are at the different places. This is associated with oxygen, therefore equivalent factor is how much? 1. But here all are like at the same place only, so equivalent factor should be same, but not. Okay. So equivalent factor is different for different. Here H3PO3 PO4 is 3 and for it is 2 and for it is 1. Is it understood? How to decide? Okay. For oxo acids only, there are this rule is applicable for which acids? Oxo acids. Okay. For hydrocid, there is no such rule. Okay. Because HCl, there is that I will tell you after explaining this one. Okay. So here all of them are H3PO4 only. Okay. So in first one, this is the structure. Okay. And in second one, this is the structure. Third one, this is the structure. Okay. These are the structures of all the three different acids. Okay. See here. H3PO4, 4 oxygens, 3 hydrogens. 3 hydrogens, 3 oxygens. 2 oxygens, 3 hydrogens. Is it understood? Now, on careful observation, what observation? On careful observation, you can find that all hydrogens are associated with oxygen. Okay. So the equivalent factor is how much? 3 here. Okay. Now here if you see only 2 hydrogens are associated with oxygen. This is not associated with oxygen. So equivalent factor is how much? 2. Okay. So here equivalent factor is how much? 1. So equivalent factor formula is number of hydrogen directly connected to oxygen. But this rule is applicable for which acid? Oxo acids only. Okay. In which oxygen, hydrogen, tertiary acids. Binary acids are there, tertiary acids are there. Oxo acids are part of the tertiary acids. Okay. Binary acids are what? Part of the tertiary acids. Okay. So here tertiary acids. These are the oxo acids are tertiary acid. All the hydrogens are connected to oxygens. Therefore, 3 here, 2 here, 1. Like that, equivalent factor will be different even though number of hydrogens of all of them are same. Is it understood? Okay. Any doubt about this? I don't think there is any doubt. There is a scope of doubt. No scope of doubt. Okay. So like this for acids, now you are comfortable. Equivalent factor. Okay. So once you know the equivalent factor, divide the molecular mass with the equivalent factor, then you will get equivalent mass. Then divide the mass by equivalent mass, you will get equivalent moles. Equivalent moles are also called as equivalents. Okay. For acid, I think don't no doubt. Okay. Now there is one exception, H3BO3. Okay. So here also that rule is not applicable. Okay. Even though boron in H3BO3, all hydrogens are connected to oxygen. Okay. All hydrogens are connected to oxygen, but equivalent factor is not 3. Equivalent factor is how much? 1. Because it does not lose 3 hydrogens, rather it gains 1 lone pair. Understood? What lone pair? OH from the water and H plus will be released. So the number of releasable hydrogens are how many? 1. Okay. So for H3BO3, even though number of hydrogens connected to oxygen are 3, equivalent factor is how much? Only 1. Why it is understood? Instead of losing this H plus, it will gain OH minus from water, and that H plus it is going to liberate. Is it understood? So first part of the equivalent factor of acid, I think everybody understood. Okay, now we are into the next part for bases. Okay, for bases equivalent factor. For base equivalent factor is simply number of ionizable OH minus. Okay, so CaOH whole twice gives Ca2 plus 2OH minus. So it is losing 2OH minus, therefore equivalent factor is how much? 2. And for KOH it is K plus OH minus. Therefore equivalent factor is how much? 1. Likewise, we can find out the equivalent factor for every base. Now let us see what is the answer for this BOH whole thrice. What should be the answer? 3 or not? But not, because it is not at all a base. It is a acid. Just to confuse you, it is given like this. Okay. Normally you will see this as this H3BO3, but actual answer your H3BO3 just now we have discussed it or not. So BOH whole thrice and H3BO3. That is why. So avoid to skip. If you skip, you will skip the marks also. You may not get the full marks. So try to watch the video from starting to the ending. Okay. Okay, for salts. Now we are going to the third part for salt. In last I am going to give you one wonderful example. Compound is same, but reaction is different. Their equivalent factor will be different. What is that question? Wait for it. Okay. So for salt like KCl, MgSO4, CaNO3. So for salt equivalent factor, okay, equivalent factor is equal to total positive charge or total negative charge, because total positive charge will always be equal to total negative charge in case of a salt. Salt is a neutral. So when positive is completely neutralized by negative, then only it will be neutral. Okay. So for example, +1 -1, +2 -2, +2 -1 into 2, it is -2. So here equivalent factor is how much? 1. Here equivalent factor is how much? 2. Here equivalent factor, total negative charge is -2, total positive charge is +2. So equivalent factor is how much? 2. Okay. Now let us do some complicated examples. +2 into 3. How much it is? +6. Okay. -3 into 2. It is -6. So answer will be how much? 6. Okay. So +3 into 2, how much it is? +6. -2 into 3, -6. So for this also equivalent factor, how much? 6. For salt, it is very easy. Okay. Let us take another example of Ca. Um, hmm, CaHCOO whole twice. Okay. The calcium formate, what it is called as calcium formate. Otherwise, sometimes it is written like this. Okay. So because actually it is negative, it should written right side, but to make it comfortable, it is written like this also. Okay. So here -1 into 2, -2, it is +2. Okay. So like that equivalent factor for salt is very easy. Next, what I told you, equivalent factor of ions. Okay. Okay, now let us come to the fourth part of it. Now let us come to the fourth part of it for ions. Okay, for ions formula is equivalent factor is equal to residual charge. Which charge? Residual charge. After completely separating from the molecule, whatever the charge left over it, it is called as a residual charge. Okay, so nitrate NO3 minus. So residual charge is -1, so equivalent factor is 1. Okay. Sulfate SO4 2 minus. There is -2. Charge is how much? 2. Okay. So there is a question, right? That normally, whenever I am free, I will give you a question of the day. Okay. In one of the question I have given as a nitrite. Okay. Just one single word it was there, and people used it as a N-3. Okay. So like this mistake, I don't want to being a student, being a regular visitor of the which chem. Okay. This is nitride IDE. Okay. What is this? IDE. Is it understood? And if it is ITE, it is NO2 minus. If it is ATE, then it is NO3 minus. See, one small word can change a lot. Okay. Let us see here ferrous Fe plus 2 equivalent factor is 2. Ferric Fe plus 3 equivalent factor is 3. Okay. So always equivalent mass of the ic salt will be less than the us salt. Okay. This is a rule. Equivalent mass of ic is less than equivalent mass of the us, whereas equivalent factor of the ic is more than the us. Factor more, mass less. Equivalent mass is less. Equivalent moles will be more again because it is in the denominator part. Okay. Any doubt about this? So I will give you clarification like this. One more. Okay. So I will explain this part. Listen very carefully. Okay. Students are requesting that sir explain this once again. Okay. Suppose nitride. Okay. Nitrite, then nitrate. Okay. So these are the three different things. What are these? These are the three different things. Here it shows that -3. It shows that -1. It shows that -1. What is the difference? Oxygens. ID means no oxygen at all. IT means less oxygen. AT means more oxygen. Okay. See, all of them are appearing to be same or not. Okay. So, but it makes a lot of difference. Is it understood? That is the difference between IDE, ITE, and ATE. Now, let us see about the ferrous and ferric. Okay. So, I will write that logic also. Suppose us, for us, equivalent factor. Okay. Equivalent factor is less. Equivalent factor is less, therefore equivalent mass will be more. Okay, and equivalent moles will be less. Okay, so if there is a ic, then equivalent factor is more. So equivalent mass will be less. Equivalent moles will be more. Okay. Suppose if you are given with 5.6 grams of iron. Okay. So if it is Fe plus 2, if it is Fe plus 3, this is ferrous, this is ferric. Okay. Here equivalent factor is how much? It is 2, and here equivalent factor is how much? 3. Is it understood? And equivalent mass will be 5.6 divided by, sorry, 56 divided by 2. Okay. And here equivalent mass will be 56 divided by how much? 3. So, but equivalent moles, suppose 5.6 divided by 56 by 2. And here 5.6 divided by 56 by 3. So this 3 go into numerator, this 2 go into numerator. Here 3 is more, that's why equivalent moles are more. Here 2 is less, equivalent moles are less. Okay. So this is the logic with example. Is it understood? Equivalent factor, how it is going to be affected with one single word, us and ic. IDE, ITE, ATE. Is it understood? Now this is all for the fourth part. Now we are going to enter into the very important part. What is that? For reactions, for redox change. Okay. For redox reaction or for redox change. Here formula is for redox reaction equivalent factor is Change in oxidation number. What is the answer? Change in oxidation number. Okay. So how it is and what you have to do, listen carefully. Okay. So let us take KMNO4. KMNO4 in acidic medium. In acidic medium changes to Mn plus 2. Okay. So the like HCl is used MnCl2, H2SO4 is used MnSO4. I have made a complete video purely for KMNO4. How to remember the equivalent factor for KMNO4. There is a one video tricks to remember equivalent factors of KMNO4 in different medium. Go to that what do you call playlist. In tricks you will find out this. Okay, that the very important topic I reminded you. Okay, for this I am going to just explain in rough. So before reaction its oxidation number is +7 and after reaction oxidation number is how much? +2. So change in oxidation number is how much? Only 5. So here equivalent factor for KMNO4 in acidic medium is how much? 5. In acidic medium it is how much? 5. Is it understood? For redox reaction equivalent factor is equal to change in oxidation number. Change in oxidation number. Now I told you I will give you a question, wonderful question which is very difficult and important. Okay, wait for it. Okay, suppose oxalic acid, very famous acid. Oxalic acid is what? COOH whole twice, like this. Okay, what is its equivalent factor? Equivalent factor is 2. Okay, but when you are to write like that, when you are given only compound, understood? So, but here this type of reactions if they give COOH converted to CO2. Okay, so COH whole twice. So in this reaction, in this compound, if you find out the oxidation number, it is +3. And in CO2, what is the oxidation number? +4. So +3 converted to +4. Change in oxidation number is how much? 2. So equivalent factor, if this reaction is given, use redox concept. And equivalent factor is how much? 2. Suppose this is the reaction given. In this reaction, what is happening is only one hydrogen is replaced with metal. So equivalent factor is how much? 1. Okay. So according to the reaction also compound, only oxalic acid is given. Equivalent factor is how much? 2. Oxalic acid with redox change like this it is given. Equivalent factor is 2. Oxalic acid is like this equation is given. Equivalent factor is 1. Compound is same but as per the question its equivalent factor can change. I hope all your doubts of the equivalent factor clear now and you will be master. I think you are now master of the equivalent factor concept. All the best, use it in every place and get good marks. Bye bye.